Resistors in parallel. We aim with this experiment to determine the effect that resistors connected in parallel have on total resistance, total current, and total voltage in a circuit. We expect that resistors in parallel are current dividers. Total resistance in a circuit will decrease. The voltage over the parallel resistors will remain the same as the total voltage. Total current in the circuit will increase when we have resistors connected in parallel.
Now let's have a look at a parallel circuit. What happens to the current and the potential difference when we increase the number of resistors, but this time in parallel. Our circuit, again, from the positive terminal of the voltage source, we go to this resistor. We've got the 15 ohm resistor, and then connected to that is a current probe. We'll just start off with one resistor, and let's have a look at what the current is and what the voltage is in this basic circuit. If we switch on the voltage source, there's our readings. The current with just one resistor is 0.22 amps, and the voltage is 3.04, and that's the same as the voltage from the voltage source. Now, let's add another resistor in parallel to this one, and let's have a look at what happens to the potential difference and the current. I have connected a second resistor in parallel to this one. So if you follow the path of current from the voltage source from the positive terminal, the current goes through here, and then it splits. Some goes through this resistor, 15 ohm, and some goes through that one, and then it comes and it rejoins back here, and then we've connected a current probe or an ammeter in series in this entire circuit. Now have a look at what the current is now that we have got a second resistor in parallel to the first one. The previous one, the current was 0.22 amps. Now the current has gone up to 0.42 amps when we add a second resistor in parallel. Now let's have a look at the potential difference. Again, from the source, we're getting about 3 volts. Now if we connect the voltage probe or the voltmeter across the one resistor, the potential difference is still 3 volts, and we move it and we connect it across the second one. The potential difference is still 3 volts. Although, so when we have these in parallel, the potential difference here is the same as the potential difference here. Now we're going to move the ammeter, because as it sits, it's reading the total current in the circuit. So we're going to move the ammeter and put it here to read the current in this resistor. And then from here, we're going to put it here to read the current in this resistor. Take note of what the total current is, about 0.44 amps. All right, now here's our ammeter or our current probe. It is now connected, reading the current going through this 15 ohm resistor. And we're going to switch it on and see what the current is here. There's your value for the current. The current is now 0.19 amps. So the current that goes through this one resistor is 0.21 amps. So now we're going to move it from here, from reading this current to reading this current. We've now moved the ammeter to this resistor to read the current in the second 15 ohm resistor. Let's have a look at what the current there is. There you have it. So the current here is very similar to this one, 0.20, 0.19 amps. So that's basically what happens to the potential difference and current in a parallel circuit.
In the first circuit, we connected a resistor of 15 ohms in series to a battery or a voltage source. The total voltage, or the voltage measured over the battery, was 3 volts. The resistance was 15 ohms. The voltage over the resistor was 3.04 volts, which is very similar to the total volts, and the total current was 0.22 amperes. When we connected 2 resistors, each of 15 ohms, in parallel, these were the results. total voltage was again 3 volts. The total current was 0,44 amps. The voltage over resistor 1 was 2,98 volts, and over resistor 2 was the same, 2,98 volts. The current through resistor 1 was 0,19 amperes, and through resistor 2, 0,2 amperes. The total resistance of the parallel connection is calculated in this way. 1 over resistance total is equal to 1 over the resistance 1 plus 1 over resistance 2. Since they were equal and both equal to 15, we calculate it as 1 over 15 plus 1 over 15. This gives us 2 over 15. The total resistance then of the circuit, if we invert this, is 7,5 ohms. The conclusions are as follows. The resistors are current dividers, since the current flowing through resistor 1 plus the current flowing through resistor 2 is approximately equal to the total current in the circuit. The voltage over resistor 1 was equal to the voltage over resistor 2, and both of them were equal to the total voltage. The total resistance in the circuit was reduced from 15 ohms to 7,5 ohms. The current in the circuit was doubled. This implies that it is a much more effective way to connect resistors in parallel than it is in series.